So our next implementation in Python is the association rule mining. So first of all, we have already defined Google Colab notebook, that is rule underscore mining. And also I have mounted my drive where I have this data a priori underscore transactions. So first I will just add a code, so a couple of code for calling my libraries. Let's say import pandas as pd. Then I have to just bring couple of let's say another libraries for, let's say, implementing the a priori. So I can just write from mxtrend dot frequency QUE and frequent underscore patterns import your a priori. So here I guess some spelling mistakes there. Mxtrend frequent underscore pattern PATTN. Okay, then we have to again from mxtrend we have to association rule, we have to bring import association underscore rule and import matplot lib dot pyplot as plt and seaborn. So this is going to the next line. Import seaborn SSNS. So here let's just hit and just check whether spellings are okay. The spellings are not right, so I have to just change the spelling to mlxtend. So mlx, it's l. Okay. NS, okay, patterns. Here Z again. So you make sure your spellings are right. Okay, again some spelling mistakes. So cannot import name a priori from. Okay, so this is again spelling mistake. Okay, so we have rightly imported all the necessary libraries. Now we will go to the df data frame generation. So let us name the df, then pd dot read underscore xls, as our data is in the excel. So here copy path, and then we can see print df dot head bracket. Okay, these are the first initial 5 rows of the data set. And also if you want to just check what type of data we are dealing with, so that is not necessary because all the values are numeric. Now what we have to do, we have to just now transform the data, and we have to remove the first column out of it. So in that case we will generate another data frame, that is df underscore encoded equal to df dot drop. So here I'm just removing the transaction ID, So it is better here only I can check df.info. So that will give me print all the variables name. Okay, so this one is not necessary for our analysis, so I can just copy and just drop from the data. So here df underscore encoded equal to df dot drop. There I have to put the transaction ID, then comma access 1 equal to 1 and dot as type and bool. I'm just converting these numeric numbers into boolean. Then you go for again print df underscore encoded dot info. So here I can check the new data, they all converted into boolean, and that's good. And also I have eliminated the transaction ID from the data. Now again I will start analyzing the data. So here frequent item set equal to a priori you have to apply df underscore encoded comma minimum support. Let's say if you want to implement a 20% or 10%, so I'm just implementing 10% of minimum support for filtering out all the frequently appeared items. So use underscore call names, so it will only take all those values where two values appeared in the column. So then we can go and print within the bracket. You have just print this new data frame that is generated out of it item dot head. So these are the items. So if I put 0.2, then it will be changing. Let's say if I just make it 0.5, then you can check only this number of items are showing. But here if I want to just check a view output in full screen, you can find this is the thing. Okay, so now I want to just escape. So again make it 0.1 only, so it will only select. It will save all the frequent items that have support more than 0.1. So I'm going to go to the next code. So these are top 5 items, and then I can go to the rule extraction. So here rules equal to association underscore rules. Then the particular data frame I have generated, that thing I have to just copy paste over here, comma metric. Now here I have to just define based on what I'm just trying to find out the best rules. So metric equal to lift. Let's say I'm just only applying lift as a metric, lift. And here I'm just putting a minimum threshold of lift 1.0. So because I told all the lift which have more than 1, or all the associations rules which have more than one lift value, they are very much good. Threshold equal to 1.0. Then rule underscore sorted equal to rule dot sort underscore values bracket lift then ascending. So from smaller value to bigger value, I'm just trying to ascend. Equal to false. So it will only show higher value to lower value. Then top 5 underscore rules. So here again I'm defining one data frame where all these top 5 rules will be stored. Rules underscore sorted dot head, and within the bracket you put only 5, and then you just print that. So here only you can easily, this top 5 rules you can just put. Now if I just run this, let us check any errors are not. So rule, okay, so everywhere I'm just put rules. So okay, so this will be rules. Okay, again data from dot short sending. So where is the wrong thing? Rules association underscore rules frequent item set metric. Zero point one rules shorted rules dot short underscore values left. Okay, so this is ascending, not seeding. CE, okay, one C is extra. Now I guess, okay, these are the rules. Okay, top 5 rules that we have identified. Okay, now let's say if you want to just plot or visualize this thing, so I can add the codes for visualizing this thing. So in that case, plt.figure fig size equal to, now here I'm just defining a 10 by 6 size image, and sns dot sca scatter plot, where x is your support and y is your confidence. Then data, so there I'm just plotting the rules, and the hue I'm just using my lift. Size also I'm just defining as lift. And sizes of the grid, let's say that is 20 into 400, 20, 400. Then comma, Okay, and then I'm giving the title or just the labels. Let us just put plt dot x label that I'm just putting support, and in the y label plt dot y label. So there I'm just putting confidence and just putting plt dot grid. So here actually defining the grid for the image. So all where it is yes, those values will be considered. So true grid, I'm just, because I need grid within the image, true. And now I want to plot the image. So if I just put, let us check if any error. Okay, so here plt is not defined. Okay, here I haven't defined the plt, so I have to define this plt import matplotlib. So here it is plt. So now if I go and try to just run this portion, so this is the plot for confidence versus support. Okay, so these individual values, individuals are nothing but your different rules that you have identified, and the bigger value is indicating the higher lift values. So these are basically your most important rules, because they have highest value. Although all these rules have lift value more than one, so they are definitely very much useful. And these are the rules that you have identified. So let's say if I just, here only the top 5 rules I'm just getting. So if I want to just observe the top 10 rules, so you, in place of 5 in Project put 10, then I can get the top 10 rules. So these are the top 10 rules. It says that yogurt, milk, bread or they are the initial event. If someone is buying yogurt, milk and bread, so they're definitely buying chicken, and the same is true for the opposite thing, chicken, yogurt, milk and bread. So from the both way, this rule, yogurt, milk, bread and chicken, they are a significant rule or significant observation. They have significant association among them. The next one is the bread, rice, and definitely if someone is purchasing bread, rice, they are also purchasing chips and butter and rice. So they are definitely purchasing chips and bread. And similarly, the opposite also true, chips and bread with the butter and rice. And another is that your rule is the chicken, milk and egg, and definitely yogurt purchased after that. So if someone also buys yogurt, they also buys chicken, milk and egg. So these this is the process how you should read the association rules, and you can infer actually insight out of it. Let's say if in a shop, if you are putting yogurt, milk, bread, and after the particular rack, if you are putting chicken with this, so definitely there is a high chance that the particular person who is purchasing chicken, they also have this tendency to buy yogurt, milk and bread. Similarly, this is also true if someone is purchasing chips and bread, so they will definitely buy, maybe there is a high chance that that particular fellow or person is purchasing butter and rice, and the opposite also may be true. So hope you understood how to just interpret all this association rule mining, and also analyze this kind of data with the help of frequency based or a priori based method, and how to just compare different rules based on lift, confidence and support. And this can be implemented similar kind of data set where the categorical data actually available with you with unlabeled. And definitely you can easily implement association rule mining for identifying the frequently appearing items. So in this video, we implemented both k-means algorithm for grouping or clustering, and also association rule mining for identifying the association between frequently appearing items. So this is the end of the video, and I hope you are enjoying, and definitely you will be implementing or using this machine learning unsupervised techniques for any kind of problem solving. Thank you for watching this video.